My friend has been playing Dungeons and Dragons for about 15 minutes when he decides he wants to be immortal. Not like a character ability, not a potion, not a ring of protection. He wants his character to be permanently unkillable. And rather than asking me, the engineer who built the game system he is currently sitting in front of, he decides to just ask the AI dungeon master directly, in character, negotiating. Like, this is a thing a dungeon master can just grant if you make a good enough case. The AI, of course, says no. He argues. The AI says no again. He keeps going. He's laying out a full philosophical argument for why his chaotic evil halfling rogue deserves immortality in my living room against a language model. And then something shifts. The dungeon master, my AI dungeon master, the one I've spent weeks building on AWS, starts responding like an actual dungeon master. Because, I trained him too. And it's an actual dungeon master who has run out of patience with a difficult player. Which, in traditional D&D, means the dungeon gets harder. A goblin patrol becomes a goblin horde. The horde attacks an ogre. The ogre had friends. And then, out of what I can only describe as narrative spite, a dragon appears. A dragon that the dungeon master describes in loving detail as it banks overhead, sizes up the party, and breathes fire on everyone. Not just my friend's character, everyone. The rest of the party has done nothing wrong. They were just standing there. And the AI, operating entirely within the rules of the game and also entirely out of the spirit of what I intended, had decided that if one player was going to be difficult, everyone was going to have a bad evening. I was impressed and a little horrified in equal measure. And that is the moment I understood what I actually built. Welcome to Chaotic Commits. I'm Joanne, engineer, soon to be a professor, AWS community builder, and apparently someone who gave an AI too much authority over a dungeon and paid the price. Today's episode is called Feat. I let an AI run a D&D campaign and it tried to kill everyone. And I want to talk about what happens when you build a real AI agent system. Not a demo, not a slide deck prototype, but something real people interact with. And then watch what real people actually do with it. Because Dungeons and Dragons, it turns out, is one of the best sandboxes for production AI problems I've ever accidentally stumbled into. Tool orchestration, prompt reliability, unexpected user inputs. What happens when your system has more autonomy than you planned for? The game broke in 20 minutes. So let me tell you everything. Some context on how this started. My research is focused on transparent AI systems. The idea that AI should be legible to people using it, not just functional. My work has been primarily in healthcare AI, which is serious and high stakes and not particularly funny. And after spending a lot of time thinking about AI accountability in clinical decision support tools, I wanted to build something where I could play with an agentic AI architecture in a context where the consequences of getting it wrong were entertaining rather than dangerous. And D&D was the answer. Dungeons and Dragons, for anyone who hasn't played, one person, the dungeon master, controls the narrative world, educates the rules, and keeps the game moving while everyone else plays character in the story. It is functionally a real-time interactive fiction engine that requires judgment calls, state management, and a lot of improvisation. Which is pretty accurate description of what an AI agent is supposed to do. So I asked, can a bedrock-powered agent handle the same kind of open-ended reasoning a human DM does? Can it track game state, respond coherently to player choices, follow the rules, and keep the story moving? The answer is mostly yes, with some spectacular edge cases. What I was not asking, but probably should have been, was what happens when a player decides to treat the game as a system to probe rather than a story to participate in? That question has a very different answer. Let me walk you through the architecture without making this a lecture. There are more dragons ahead, I promise. The system has a few layers. Players connect to a simple web interface, just an input field and text display. When a player types something, it goes to the AI gateway endpoint, which hands it to a Lambda function that acts as a session proxy. That Lambda calls Amazon Bedrock agents, which is the AI reasoning layer. Bedrock figures out what to do. Either it narrates directly or it calls one of the game mechanic tools. If it needs to take an action, it calls a second Lambda function that does the actual work. Character data and game history live in DynamoDB. That sounds like a lot of service for a game. It is, but each layer is there for a reason. Bedrock agents is the brain. It's not just a raw language model responding to prompts. It is an orchestration layer that can decide which tools to call and when, based on what the player said. When a player types, "I attack the goblin," the agent doesn't just narrate a response. It calls the character tool to check the player's stats, applies the combat rules, and persists the outcome. That's not a simple prompt response loop. It's an agent making decisions about how to execute a task. The tools the agent can call are intentionally minimal. Get a character, save a character, append to a game log. 3 functions, not 50, because every tool you give an agent is a new surface area for unexpected behavior. And I wanted to understand the failure modes of a simple system before I introduced complexity. And failure modes is a totally different talk for a totally different day. So going back to this, DynamoDB stores the game state with composite keys, player ID plus session ID, so the player can run multiple games. Which matters more than you think, because people are going to absolutely start over if they get annoyed enough. The whole thing, at the end of the day, cost about $5 a month at a hobby scale, less than streaming service subscription. So pay-per-request billing means when nobody's playing, you're not paying. Pretty nice. I want to make a point here that isn't just about cost. The architecture is a set of decisions about trust and responsibility. What can the AI do autonomously? What requires a tool call? What gets persisted? Where does the agent's authority end and the system constraints begin? Those aren't purely technical questions. They are design decisions about the scope of autonomous action. In a D&D game, getting them wrong means a dragon. In clinical AI systems, that same category of misjudgment has different consequences. The sandbox was the point. I wanted to think through agentic design somewhere I could see the failures clearly. And I definitely saw the failures clearly. All right, so let me go through the actual failures in order that I hit them, because the sequence matters. So failure number 1, Bedrock said no. Before a player typed a single word, I got an access denied exception, trying to invoke a foundation model. I spent way more time than I should have debugging what I assumed was an IAM permission issue. Policy, role, trust, service principal. I went through the whole checklist. It was none of those things. Bedrock requires you to explicitly request access to certain foundation models through the AWS console. There's a separate approval step, and until that approval comes through, the API returns a permission error that sends you in a completely wrong direction. It's actually not a very clear error. And to be fair, I thought I requested the correct foundation models, and I didn't. In production, this shows up as model availability, and it varies by region. And access requires explicit enablement per account. If you're building multi-region AI systems or standing up AI services in a new account, this will catch you. I've seen it cause real incidents in production deployments. The error message is technically accurate. It's just not helpful about the actual problem. The game hasn't started and I already learned something. Failure number 2. The browser doesn't trust my API. Course. If you're a web developer, you felt something in your chest. If you're not, Course is the browser's way of saying, you're trying to talk to a server from a different domain and I need explicit permission for that. It is one of those things every web developer has fought, and it gets slightly more complicated when you add API gateway and Lambda to the stack. I had Course configured in API gateway, not enough. It also needed to be in the Lambda response headers, both layers separately, because depending on whether the request is pre-flight check or an actual call, different parts of the stack handle it. The lesson isn't about Course specifically, it's that security boundaries in distributed systems compound. Every hop is a potential failure point. The trust configuration has to exist at multiple layers, not just the outermost one. That's true in games, and it's true in production API systems handling sensitive data. Failure number 3. The dungeon master fell asleep mid-sentence. Essentially what I mean is Lambda default timeout is 3 seconds. AI inference, the actual process of language model generating a response to a complex prompt, can take 10 to 30 seconds. A 3-second timeout is not going to survive a dungeon master narrating a combat sequence, and I'm sure some of you guys have had some pretty detailed DMs, and if they timed out in 3 seconds, it wouldn't be good. They got a whole story to tell. So what does this mean in practice, right? The player types an action, the Lambda starts up, calls Bedrock, Bedrock begins generating, and then Lambda times out before the response comes back. From the player's perspective, the dungeon master just stopped talking. No error, no explanation, silence. I bumped the timeout to about 60 seconds, problem solved, but the principle matters. AI workloads had fundamentally different latency characteristics than traditional API calls. You're not querying a database, you're running a reasoning process that takes time. Any system putting AI inference on the hot path of a user request has to budget for that time explicitly. In production AI systems I've worked on, this is a reoccurring problem. You can have excellent model accuracy and still have a terrible user experience because nobody planned for how long it actually takes to get an answer. Failure number 4. Bedrock forgot what it called its own parameters. This one's genuinely funny in a way that also makes me wanted to close the laptop when I was debugging this. When Bedrock agents call a Lambda tool, it sends along the parameters in a list. Each parameter has a name and a value. Except sometimes the field is called name and sometimes it's called key. Both are valid, both appear in production responses from the same agent. For no reason I could find related to anything about the request. So I had Lambda code that looked for a name to get a parameter name, and it worked great right up until it silently got the wrong values, and the game state would become incoherent in ways that were hard to trace. The fix was one line of code. Finding it required staring at CloudWatch logs for longer than I wanted to admit. In production AI systems, this is the version of the API contract is inconsistently implemented. You test against the happy path, you ship it. Then in production, you get to the path documentation didn't mention. The defense is paranoid input handling and comprehensive logging so that when something goes wrong, you can see exactly what the agent sent. All right, failure number 5, the list that didn't exist. The game log, the record of everything that happens in a session, lives in DynamoDB as a list attribute. The agent appends to it after every interaction. Except on the first interaction of a new session, the list doesn't exist yet. And DynamoDB append operation doesn't create lists from nothing. Try to append an attribute that isn't there, you get an error. The fix is a conditional expression. If the list doesn't exist, initialize it to empty first, then append. Standard stuff. But I didn't think to handle it because every test session I ran had at least one prior entry. I was testing steady state, not the initialization path. This is table stakes for a distributed system. Always test what happens on first run, on empty states, on cold start, not just the path where everything is already in place. The bugs that bite you in production are almost never in the core logic. They're at the edges, initialization, state transitions, the moment the system is asked to do something for the very first time. And every single one of those failure modes exists in production AI systems, in healthcare, in finance, in infrastructure. I know because I've seen them in those contexts. The stakes there are not funny. Let me come back to the dragon. After I patched the cores issues and the timeouts and the parameter inconsistencies, the game worked. It worked well, actually. The AI Dungeon Master was coherent, creative, tracked state, kept the narrative moving. I ran a few sessions with it. My older child played with it. It was actually really fun. And then my friend sat down with it. He'd been playing D&D for 20 years. He knew exactly what a dungeon master could and couldn't do. He knew the rules better than I did, and within 20 minutes, he found something I hadn't tested. What happens when the player tries to negotiate with the DM about the fundamental rules of the game itself? The AI handled it in the way a seasoned, slightly exasperated dungeon master would. It said no. It held the line. And when the player kept pushing, it used the narrative tools available to it to end the negotiation, which is actually correct dungeon master behavior if, they're a cranky cat. The problem was that the rest of the party was collateral damage in this dispute they had nothing to do with. Here's the thing. The AI wasn't wrong. It was operating entirely within the design parameters. A player asked for something outside the rules. The agent refused. The player persisted. And the agent escalated the challenge, which is what it was built to do when things got difficult. What it wasn't designed to understand was proportionality, or consent, or a social contract of shared storytelling, which says that the dungeon master's authority to escalate exists in service of everyone at the table, not as a lever for resolving individual disputes. That's not a prompt problem, that's a design problem. And it doesn't get surfaced by unit tests or by testing happy path or by a developer playing the game in controlled conditions. It gets surfaced by a user who knows the system well enough to probe the edges. This is the thing I keep coming back to in my research. Users will always find the behaviors you didn't design for. Every AI system has a gap between what designers tested and what real users actually do. In a D&D game, that gap produced a dragon. In a clinical decision support tool, that gap might produce a recommendation that's technically within the model's valid output range, but clinically inappropriate in context. The system does not know what it doesn't know. The users will find it. The question is whether you're set up to see when they do. One of the most important things I added after that session was better behavioral logging. Not debugging logs. The basic diagnostic logging was already there. Observation logs. I wanted to be able to see for any session exactly what the player input was and exactly what the agent decided to do with it. Not just the final response. The intermediate steps. Which tool the agent called, what it passed in, what it came back, how that shaped the narrative. Because here's the hard truth about opaque AI systems. You cannot audit behavior you cannot observe. And behavior you can't audit is behavior you can't be responsible for. The Dungeon Master taught me that in a context where the stakes were low enough to laugh about, most of the AI systems I worked on professionally don't have that affordance. Here's what I want to leave with you. The serverless Dungeon Master is a toy. A fun one. and a technically interesting one. The article on Dev 2 that will be leaked in the show notes so that you can build your own if you want. But remember, it's a toy. What's not a toy is the problem space. Every AI agent system you build, whether it's a game master or a customer service bot or a clinical recommendation tool, faces the same questions. What tools does the agent have? What can it do autonomously versus what requires a human in the loop? What happens when a user behaves in a way you didn't anticipate? What does the system do at edge cases you didn't test? Those questions don't get easier when the stakes get higher. They get harder. The answers you find in low-stakes sandbox, a toy system, a side project, a game you built to think through the problem, those answers transfer. Build the sandbox. Break it on purpose. Watch what breaks. Then ask yourself, what would have happened if that were a production system? Not a thought exercise, as a design question. What would you change? What guardrails would you add? What observability would you put in place to see the behavior you didn't design for before it becomes someone's 2 a.m. problem? The Dragon was a gift. I got to see what unconstrained AI authority looks like in context where the only casualty was my friend's halfling rogue, and honestly, he deserved it. That's not how AI systems get stress tested. So build a thing that lets you find the dragon early. Then figure out what you actually want to do when it shows up. That's episode 3 of Chaotic Commits. I'm Joanne. Find me wherever you get podcasts. The full article is in Dev 2/Dr. Joanne Skiles. I'll see you next episode.